Okay, ठीक है. So, okay. Okay, so in the last class, we have done the second law of motion. I've given, basically, we have done the derivation as well, right? Anam, Sar, are you there, Bachu? Anam and Sara.
Yes, sir.
Acha, acha. What happened? Why are you not opening your cameras, Anam and Sara? Is everything fine? Your voice is lagging. Acha, one more thing. Uh, how many of you have done the revision before coming to the class? Sara, Saad, and Adam. Be honest with me. Chikan, I'm dead. Sara? No. ठीक है. Saad? Saad, have you done the revision? Uh, अच्छा, ठीक है. Only Anam did. ठीक है. Anam, I think you were not present in the last class, na?
Yes, sir. I was not there.
अच्छा, ठीक. चलो. Okay. So in this class, we are going to study. अच्छा. Okay. I'm outside right now, so I don't. ठीक है, Saad. ठीक है. Okay, so in this in the previous class, we have basically derived the equation of the second law of motion, how the F is equals to ma is derived. Okay, so this is a three-line calculation, not more than that. F is the change in momentum. Okay, and if you remove that proportionality sign, what this proportionality sign will remove, and there is a k constant comes, and this k is equals to 1 by the scientific method. So only this line is written, so there is no need to go in the depth. Why is k equals to 1? Okay. So this is an F. So the remaining equation that comes out is F equals to ma. Hello, Arhan. Assalamu alaikum. Arhan, am I audible?
Assalamu alaikum, sir.
Walaikum assalam. How are you, Arhan?
I'm fine, sir.
Oh, that's good. Okay, so Arhan, I've just started the class. Okay. So I was just discussing what we've done so far in the last class. Okay. And in today's class, we are going to discuss the conceptual applications of the second law of motion. And along with that, we will do the numericals. Okay. Sure, that's good. Okay. So, okay. So in the last class, I've basically given an example to you that why, when a fielder or a cricketer is basically catching a ball, they basically like catch this ball like this and takes back in the backward direction, right? Takes the hand in the backward direction. So the reason behind that is basically ball is traveling with a very high speed. Okay. So basically to absorb that momentum, we have to take the hand of basically we have to catch the ball and basically take the hand in the backward direction to absorb or to reduce the momentum of that fast moving ball. Okay, so this is the application of the second law of motion, right? Second example is basically you can say use of the basically seat belts in the car. Okay, so basically we use put the seat belts on the shoulders when we sit in the cars. I think this. Hello, Rafi. Assalamu alaikum. How are you, dear? Am I audible? Rafi, am I audible?
Yes, sir.
Okay. How are you?
Viral.
Okay. Rafi, please switch on your camera. Arhan, you as well, dear. Okay. Okay. So basically, when the car travels like this, basically car is traveling with a speed v. Suddenly, you basically stops the car. What will happen? You will go in the forward direction because of the inertia, because you are moving. because your body is moving with the speed of the car. So basically, to reduce the momentum, the seat belt is used. Okay, because seat belt is basically placed here, right, like this in a cross manner, right? Okay, Anam, Sara, Arhan, and Rafe, Saad.
Yes.
Yes, sir.
Sure. Okay. So these are some conceptual points. Let me write it and then we will do the numerical based on that. Okay, so in the last class, I have basically asked you to revise the equations of motion as only Anam did the revision, but the rest of you have not done the revision. Arhan, have you done the revision before coming to the class of equations of motion?
Yes, sir.
Sure. Rafe,
Sir,
revision of equations of motion. Have you done that?
sir,
Check. Okay, so this is the applications of second law of motion. Please start writing, everyone. Applications. Newton's. Okay. So the first is a cricket player or a cricketer. Just a cricket fielder is better instead of cricketer. A cricket fielder moves his hand backwards on catching fast cricket. To prevent injury to the hands. Because a fast moving cricket ball large okay. So when the ball is moving very fast, so it has large momentum to prevent so that we don't have any injury to the hands. So that's why we move our hands in the backward direction. Clear, everyone?
Yes.
Okay. So let me show you the picture. How does it happen? Acha, how many of you watch the cricket or play cricket? Raise your hand in the chat. No one. Oh, Okay, Anam, Arhan, only two. Acha, one more is there, I think so. Rafe. Chalo, theek hai, chalo, that's good. Okay, okay, lower your hands. So. Yep. So when the ball is moving, see, so the person is carrying the ball is basically taking his hands in the backward direction to observe the momentum so that there is no injury to the hands, right? It works like a rubber. When we've taken the backward direction, it works like a absorbent. Okay. And I've also given one example of when we basically jump from a high place, we basically, after jumping to the ground, we do not land steadily. We just bend our knees so that our knees absorb that, you can say, shock. If we don't do that thing, so our bend, like basically our knee will break. Okay, there will be a fracture in the knees, right, everyone?
Yes, sir.
Okay.
Yes,
Yes.
sir.
Yeah. So these are some applications of the second law of motion. Okay, so second, let's take one more, and then we will, and after that we will do the numericals. Okay? All the cars provided with seat belts for passengers to prevent injuries in case of an accident. Okay. Suddenly. This large momentum is reduced to zero. In a very short time. Clear? So basically, when the you can say when the momentum of the car becomes zero, so there is a you can say when so it suddenly stops. So our seat belts basically stretch a little bit. Okay, so this increases a little bit delay in the change in momentum. So that's why the force exerted on our body is less. Okay, the slightly stretchable seats. Worn by the passenger is reduced is basically by the passenger. Increase the time taken. To fall forward. Okay. Here, everyone.
Yes, sir.
Hence, less stopping force acts on acts on. Okay. So this is the reason why why seat belts are attached in the car. Okay. So okay. Now it's time for the numericals. Okay. Because this law involves the numerical, like inertia do not involve, and the second law of motion, sorry, third law of motion. Okay. Sure. Let's do a numerical based on that. And these numericals will involve the equations of motion as well. Okay. So these are the straightforward numericals that I'm giving basically giving right now based on the. Is my screen visible to all of you?
So is the answer 24 Newton?
Yeah, it's 24. Of course, this is directly based on the F equals to mf formula. Solution. As you can see, the question is what force would be needed to produce an acceleration of 4 meters square per second square, 4 meter per second square, and the mass of the body is 6 kg, right? So according to the formula, that is F is equals to force is the product of mass and acceleration. So 6 into 4 is equals to 24 Newton. Is this clear to all of you? Which please let me know once. Any doubt so far to anybody?
No, sir.
Sure. Okay. Now let's do a question that involves the equations of motion, because the question based will come in this manner. Question is saying, let's do it together. Question is saying that calculate the force required to impart a car to a car a velocity of 30 meter per second in 10 seconds starting from rest. So the initial velocity will be, if it's starting from rest, it would be 0, right? And it has to gain a velocity of 30 meter per second. The final velocity would be 30 meter per second in 10 seconds. So time given is 10 seconds. Okay. And the mass of the car of the body is given as 1500 kg. So it means that, as you can see this question has no acceleration right now. Basically, we have to find it out from the other, you can say, quantities. So as you can see, everyone, that I have U, I have V, I have T. So can I write this thing? Can I use the first equation of motion? that is v equals to u plus at. To find out the acceleration, everyone,
Yes.
Yes, sir.
so acceleration would be v minus u by t, that is equals to 30 minus 0 divided by 10. So this is coming out to be 30 by 10. 0 will cancel this. So it is coming out to be 3 meter per second square. Is this clear to all of you?
Yes, sir.
Okay, then. Very good. Okay. Now we need to find the force. So force involves the acceleration and mass. We have mass, and now we have got the value of acceleration. So that is v equals to ma. So it is 1500 into 3. It is coming out to be 4500 Newton. So this is the answer. Please let me know, everyone. Is this clear to you or not?
Yes, sir.
Sure, that's good. Ajay, I'm giving you one question, and let's see who can solve this question. This question involves the graph along with the second law of Newton. Okay, I'm giving you 3 minutes to solve this question, and please let me know the answer. Okay, everyone, after this class, you will be having an assessment. Okay? So after this class, go and check out the assessment, and I will be sharing some questions based on the second law of motion as well. Okay? After this class. The answer from anybody, please let me know. Saad, Anam, Sarah, Arhan, and Rafi. Answer.
Sir, I got the answer.
ठीक ठीक है सर. Arhan, please let me know the answer in the chat. Okay. So, okay, now. Okay. 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 Check. Okay, everyone. Any answer by Sara, Saad, and Rafe? So I got the answer by Rafe. ठीक है, Rafe. That's good. 10 meter. ठीक है, चलो. At least you have answered. That's a very good point. Sara and Saad.
Sir, I sent you the answer in the chat.
Sara, I have no message of yours right now, dear. Please check it. ठीक है साद. Okay. ठीक. Okay, Raf. Sure. Sara, please send your answer again. I didn't get your answer.
Okay, sir.
Yeah. After this class, everyone, you will be having an assessment, okay, of the first and second law of motion combined. Okay. Sure. Sure. Let's solve it together, everyone. Let's verify who got the right answer. Okay. So let's analyze the graph first. Okay. Let me take a picture of graph only and let's analyze that. Okay. Okay. So let's analyze this graph. So before answering anything, let's analyze this first. Okay. So as you can see this thing, this is a speed time graph. So basically the significance of speed time graphs are two. First is slope, second is area, right? Okay. Now let's analyze. So basically object has started from the position A, from the origin. It means that the initial velocity was 0. And the slope of this graph is basically in the upright direction. It means that, okay, Sarah. Okay, Sarah. Okay. Then it means that the graph is going upwards. So it is accelerating, right? Am I right, everyone? Still point B, it is accelerating from A to B. In this first 2 seconds, it is accelerating. So after B, okay, when the object is at B point, it moves along the x-axis. It means that it is parallel to the x-axis till point C. It means that your time is passing, but the velocity is constant or uniform, you can say. That is 15 meter per second, right? It means that in this phase, there is no acceleration at all, right? And after that, from point C to D, the speed is declining. It means that after 6 seconds, at the 6th second, the speed becomes 0. It means that it is deaccelerating here. First 2 seconds accelerating, after that for 3 seconds, constant velocity, and last second, deacceleration, right? These are the 3 phases in this graph, right? So now we have to find out what the question is saying. Okay? So first of all, let me write all the things. weight of the car is given, that is m is equals to 1000 kg. Okay. Question is saying what is the distance traveled by the car in the first 2 seconds? It means that the distance traveled is this in the first 2 seconds, right? This. So it is basically nothing but it is the area covered in the first 2 seconds. Am I right, everyone? Yes or no?
Yes,
It is
sir.
nothing but the area covered, na? I've told you that two significance of the speed time graph. So that the second significance is the area. Okay, so and the area covered is nothing but the speed or distance covered, right? Now let's find out the area. So area is nothing but it is the area occupied by the triangle AB. Suppose this is O, or you can say P, right? This is just a second. Let me, yeah. So this is P. Okay. So the first point is just the first point is first 2 seconds will be area of triangle A B P. Am I right, everyone? Yes or no? As you can see, this is a right angle triangle. Okay, so it would be half base into height, right? So the value of AP is, you can see this thing, AP is nothing but 2 units. It means that 2 seconds, 1 unit is basically representing, I'm writing it here, 1. Because in sometimes you have to mention it. When the graph is given to you, so you have to mention the unit. It is 1 second on x-axis. One second. Okay. And on the y-axis, this you can see 5 meter per second. Okay. So everyone, you can see this thing. So AP is nothing but 2 seconds. Okay. AP is your base. Writing it here. AP is 2 seconds. And we have, and basically your PB or BP is 15. So half base is AP and PB is equals to half into 2 into 15. So this answer will come in meter, as the unit is given is meter. So this will cancel. So distance covered in first 2 seconds is 15 meter, everyone. Is this clear?
Yes, sir.
Okay. So as you can see this thing, now we have got the distance covered in first 2 seconds. Okay, now we have to find the acceleration, or sorry, we have to find the braking force applied at the end of 5 seconds to bring the car to stop, to a stop within 1 second. So in the one, we have to find the braking force that is, you can say, applied to the car to get stopped, right? Chalo. So first of all, we need the acceleration. To find the force, we need acceleration. As you can see, this is a speed time graph. So the slope of this graph will give you what? Acceleration. Speed by time is acceleration, everyone. Do you remember?
Yes, sir.
Okay? Yeah. So this would be the slope, because you can see this thing. B to C, the slope is 0. It means that car has constant velocity. So there will not be any acceleration. Okay. So in the point 2, the braking force is F is equals to ma. Everyone, yes or no? Okay. So as you can see, this thing, we have mass of the body, but we don't have acceleration. So the question is saying at the end of the 5 seconds, it means that there is only acceleration in this phase. So we have to calculate the acceleration of this phase, because at this point, car has some velocity. From this point, the car starts declining. Basically the velocity of the car starts declining. So what we'll do is that we will find out the slope. As you can see, this thing, slope of speed time graph is equals to acceleration. Am I right, everyone? Okay. So acceleration would be, and basically if I write down the slope formula, so that is y-axis. Basically it's the ratio of y-axis to the x-axis. Okay. 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 So what is y-axis here? Y-axis is 15, right? Am I right? 15. The value of y-axis is 15.
Yes.
And the value, okay, the value of x-axis is 1. 6 minus 5, it's 1. Base is 1, na? That's one, everyone.
Yes, sir.
6 minus 5. You can also write 15 here. Okay. So, no, just a second. 0 minus 15. 0 minus, because final minus initial. Here, at point D, this is the final point of the car. So at this point, the car has velocity 0. And this is the initial point from which the car starts declining the velocity. So this point will be the initial point for this point CD. So this would be 15. And the time taken is from point 6 to 5 is 1 second. So 0 minus 15 would be minus 15 by 1. So it is minus 15 meter per second square. Why there is a negative sign? Because the slope is negative. The slope is in the downward direction. I've told you that in the acceleration graph. Let's look at the screen, bacho. This is a positive uniform. There you go. The velocity of a body decreases, the acceleration is negative, so the graph will go downward direction. How many of you, bacho, remember this thing? How many of you? Clear, everyone?
Yes.
Okay. So now you got it. Why the acceleration is negative?
Yes, sir.
Right? Sure, that's good. I have taken 0 minus 15 because the final position was this. At this point, car has velocity 0, and at point C, it has 15 meter per second velocity, right? And the time taken is basically 6 minus 5, because it is an interval. It is an interval. So we have to find the exact time of that interval, right? Clear, everyone? So now we have got the acceleration that is acting on the body, and it is a negative acceleration. And the braking force would be ma, that is minus 1500, 1000, 1000. Is this 1000? 1000 into minus 15. Newton. So it is negative of 15,000. So why there is a negative sign? Because the force applied is in the opposite direction of the motion, right? Because force is a vector quantity, so direction matters to this quantity, right? So we have to introduce the negative sign as well, right? This negative sign is only showing the direction of the force applied, right? Because the motion is in this direction, we are applying the force in this direction. It is opposite. It's only the significance of the negative sign is the opposite direction of the force. Am I clear to everyone? Let me
Yes,
check
sir.
who got the answers. Okay. So Rafi got the answer of force correct. Sarah, you got the wrong answer for the force here. You got the, you can say, distance is completely right. Anam got 15,000. But you have to mention the negative sign as well here because direction matters, right? Because this is a braking force. Distance is ठीक Arhan, Arhan, you also got the wrong answer of force, that is 1500. ठीक है? So you have to check it. Rafi, you got the wrong answer for the distance here. ठीक है? So is this clear to everyone now?
Yes,
Yes.
sir.
Any doubt so far to anyone? Please tell me, is there any doubt to anyone in this question?
No, sir.
Sure. If not, please do this question, sir. Okay, I'm giving you one thing. So what is basically seven metric tons? So 1 metric ton is equals to 1,000 kgs. So 7 metric ton means 7,000 kgs. Okay, so this is the catch. Please do this question and let me know the answer. Okay, I got the one answer by Anam. ठीक है ना? सारा अरहान. ठीक है ना, ठीक है सारा, okay. Okay, Arhan, what's your answer, dear? Okay, Anam, do you have conservation of momentum in your syllabus?
Yes, sir.
ठीक है, सारा?
Yes, sir.
ठीक. Arhan? Because I have to ask specifically for each and every topic, because like you can say, because in 9th standard schools do not follow the exact CBSE pattern, they have their own pattern. But in 10th standard they have to follow, it's the, you can say, condition, because the students are going to give the boards exam. So every time. Okay, so let's find out the answer. Okay, a truck starts from the rest and rolls down to a hill with a constant acceleration. Okay, so the initial velocity of this truck is 0. It travels a distance of 400 meter. S is basically coming out to be 400 in 20 seconds. In 20 seconds, time is given as 20 seconds. Find the force, find the acceleration and find the force acting on the body. Okay, let's find out the force for acceleration first to find the force. Okay, as you can see, initial velocity, distance and time is given. It's directly saying that you have to apply the you can say the second law of equation. This is second equation of motion, sorry. Okay, second equation of S is equals to ut plus half kt square, right? So S is 400 is equals to U is 0 into 20 plus half A into T is 20 into 20, right? So 400 is equals to, this will be basically 0. This will cancel this 10 times, and A into 200. Okay, so A is coming out to be 400 by 200. So it is coming out to be 2 meter per second square, right? So from the second law of motion, F is equals to ma, that is 2 into 7,000. This would be Newton, so 14,000 Newton. That's the answer. Anam, you did a very silly mistake here. Answer is not 1 meter per second square. Okay, Sara, you got the right answer. Very good, Vijay. Okay, is this clear to all of you? Please let me know once.
Yes,
Yes,
sir.
sir.
Okay, Arhan, do you get the answer?
Yes, sir.
Sure. Okay. This was same as mine.
Yeah.
Sure, that's good. Okay. So this second law of motion is done. The only two topics are left. Third law of motion. That is a one class topic, because in that we have to do the theory, like it's nothing but action and reactions are equal. It means that if you basically you must have seen that for example, have you seen that basically in the movies and in the, you can say in reality as well, when a person shoots a gun, there is a recoil. It does it if like this, so it basically, the hand basically has a jerk, right? So this is also the, you can say, applications of third law of motion. And the only topic left is conservation of momentum after that. So that is also one class topic, because numerical based on that are very good. Okay, you can say quality. So these topics will be left. So in the next two classes, this chapter will be done. Clear, everyone?
Yes, sir.
Okay, so this is all about this chapter then in this class. And in the next two classes we will be we will complete this chapter. And the next chapter would be work energy. After this chapter we'll be doing the work energy chapter. So I hope all of you got the concept in the class.